Good afternoon, or good evening even. What I want to tackle in this video is gas stoichiometry. Now this is, I believe, page 15 of your packet. And really quickly, let's just kind of review what stoichiometry is and some key points. So going back a couple of units, remember in stoichiometry, what we are doing is taking a look at a balanced equation. And remember, we're doing a conversion where we're converting from the amount we have of one substance in that reaction to the amount of another. And then besides just kind of knowing what stoichiometry is, remember kind of the other key part is when we go from substance A to substance B, remember we use that mole ratio to cancel out moles of A to get to moles of B. Where remember our mole ratio comes from looking at that balanced reaction, in particular our coefficients. So hopefully that's kind of comes back to you as we go through a couple of these. I'm going to do a number of problems on this page because there are kind of two types of gas stoichiometry problems. And I'm going to start with the first type, which I think is probably the easier type, and that occurs when our reaction is at STP. Remember, STP stands for standard temperature and pressure. And you definitely should memorize those conditions. Remember, standard temperature, that's 273 Kelvin, which is 0 Celsius. And remember, standard pressure is 1 atmosphere. So definitely make sure you remember those. All right. So let's do number 1. And again, just kind of do our more basic, maybe not basic, this first method of gas stoichiometry when the reaction is occurring at STP, standard temperature and pressure. So number 1 asks how many moles of nitrogen gas is needed or are needed to react with 44.8 liters of hydrogen gas to produce ammonia gas. So stoichiometry, just like any conversion, first thing that we want to do is write that given. So we're given our 44.8 liters of H2. And we want to change liters of H2 to moles of nitrogen gas. That's our X. So we're going to have to convert here. Well, remember, with stoichiometry, in order to go from one substance, in this case hydrogen, to that second substance, in this case nitrogen, we have to get moles. So the first thing that we're going to have to do, I'm going to put this over 1, is we got to cancel out liters of hydrogen and go to moles. And because we are at STP, this is going to be an easier process. Talked about this back with the ideal gas law, but remember at STP, so when we are at standard temperature and pressure, 1 mole of any gas is going to have a volume of 22.4 liters. So again, when we are at standard temperature and pressure, 1 mole of any gas is going to occupy that volume of 22.4 liters. So that's going to be our conversion factor between liters and moles. Just like if we do a molar mass for moles and grams, or we can use Avogadro's number for moles and particles, if and only if we are at STP, we can use the conversion 1 mole equals 22.4 liters to convert between those two units. So that's equivalent to 1 mole, and we know it's 22.4 liters, so paying attention to our units, liters cancels out, and now that we have moles of hydrogen on top, now we can go to our mole ratio step where we can put moles of H2 on the bottom and moles of what we want to convert to, in this case nitrogen, on top. And again, this is our mole ratio step. And we always go back to our coefficients for mole ratio. So that's a coefficient of 1 in front of nitrogen, and then a coefficient of 3 in front of hydrogen. So that would cancel out moles of H2 Oh, and look, the only unit I have left is moles of nitrogen. So now just to do the math, just 44.8 times 1 times 1 divided by 22.4 divided by 3. And then watching our significant figures, I think there should be 3 of them. Go back to the given. 0.667 moles of N2 would be our final answer. So again, you can see at STP, life is a little bit easier. But let's try this next one. Actually, you know what? As I think about this, let's actually maybe try number 3, if I can make this work. There we go, that's what I want. Let's try number 3, actually. So number 3, different equation, different reaction. Let's make sure it's balanced first. Probably should have said that a little bit more with number 1. So number 3, when 11.2 liters of hydrogen gas at STP is made by adding zinc to sulfuric acid, what mass of zinc is needed? Okay, so we know it's stoichiometry. We have that balanced equation. We are converting liters of hydrogen to mass of zinc. So we know our first thing that we need to do is to write our given. We have our 11.2 liters of H2. And again, I want to change liters of hydrogen to mass of zinc. So I know with stoichiometry, my first step is I have to get moles. If I'm not given moles, I got to change it to moles. And because we are at STP, we can use our conversion that 1 mole of any gas occupies that space or volume of 22.4 liters. And now that I've converted to moles of hydrogen, now we should recognize mole ratio, where what goes on the bottom? Moles of what we want to cancel. And what goes on top? Moles of what we want, in this case, zinc. And then what do we look at to fill this in? Coefficients. Zinc, coefficient of 1. Hydrogen gas, coefficient of 1. Moles will cancel out. But unlike number 1, reason why I wanted to do this, it asks for grams. So we have to add one more step at the end here. We don't want to end with moles of zinc as our only unit remaining. We need to cancel out moles of zinc and make that grams of zinc. So I referenced this earlier in the problem. Remember, how do we convert between moles and grams? That's right, we use our molar mass. So I put a 1 there, and then I can go to my periodic table, which if you don't have your paper periodic table, ptable.com is a great reference to have up. And our molar mass of zinc is 65.38 grams. So moles will cancel out. And look, we're just left with grams of zinc. That's it. So everything is set up correct. So we do the math. So 11.2 times 1 times 1. Again, I'm just kind of multiplying everything across the top times 65.38. And then divide that by 11.2. Nope, I didn't do that right. 11.2 times 65.38 divided by 22.4. There we go. And then I should always go back and look at my given for sig figs. I see 3 sig figs there. So that final answer, 32.7 grams of zinc would be needed. So again, with this first type of gas stoichiometry problem, when we are at STP, we can use that conversion of 22.4 liters is equivalent to or equal to 1 mole to convert between moles and liters. But let's maybe take a look at number 5. And let's maybe take a look at our second type of problem here. So in number 5, we have that reaction between carbon monoxide and oxygen. And if we have 1.39 grams of carbon monoxide reacting with oxygen, we want to know what volume of carbon dioxide is produced at 12.3 degrees Celsius with that pressure of 107.4 kPa. Okay, so for this one, we want to know grams of carbon monoxide to volume of carbon dioxide. So we're looking for liters here at the end. And we're given a temperature and a pressure. So notice our temperature and the pressure, we're not at STP here. We're under non-standard conditions. That means we can't use 22.4 liters, but we'll kind of get there. We'll get there. So as I take a look at this, if I was working this out, my given is that 1.39 grams. Be careful here. Temperature and pressure, they're not going to be used in the stoichiometry setup. They're going to be used in kind of the other part of these type of gas problems. So we're given 1.39 grams of carbon monoxide. Put that over 1. And I know I want to change that to carbon dioxide. So the first thing that I would do is cancel out grams of CO, change it to moles of CO. And that would get a 1. And then I would need my molar mass, 12.01 plus 32. Grams would cancel out. Okay. Now that I have moles of CO, I could go to my mole ratio, where again, what I want to cancel out goes on the bottom, what I want to convert to goes on top. And I fill it in by looking at my coefficients. 2 from CO2, 2 from CO, so moles of CO would cancel out. And again, I might be at this point saying, okay, I have my CO2, now I can go from moles to liters. And that'd be good, right? Well, except we're not at STP. We're under, again, what we call non-standard conditions. So we'd actually have to stop at this point because we can't use 22.4. But there is another way for us to change between moles and volume when we're at or under these non-standard conditions, when it's not STP. And the key to convert between moles and liters when we're not at STP is Pivnert. So again, when it's not STP, when we're not at STP, the way we change between volume and moles is to use our ideal gas law, which I call Pivnert. Probably should have said that before. So my stoichiometry will get me moles of CO2, but then again, I can't use 22.4 liters. So I would stop with my stoichiometry, and I would do the math, 1.39 divided by 44.01, and I would have 0.0316 moles of CO2, which I would then plug into Pivnert as moles, along with my pressure and temperature, and solve for volume. So again, when we're not at STP, we're going to have to use the ideal gas law, Pivnert, to change between moles and volume. In this problem in number 5, we needed to get moles first. In other problems, you might have to use Pivnert first and then do the stoichiometry. But again, we'll kind of see this. Let's finish number 5. So I got to plug in my moles. I got to plug in my pressure. Oh my gosh, this is a real annoying problem because I know with the ideal gas law, pressure needs to be in atmospheres. So I actually have to convert this one. So 107.4 kPa. And atmospheres, 1 atmosphere is the same as 101.3 kPa. So 107.4 divided by 101.3, and that is 1.060 atmospheres. So now I can plug that in. So now my pressure is 1.060 atmospheres. I'm trying to find my volume. I have 0.0316 moles of CO2. R I know is 0.08206. I'm going to squish this together a bit here. Temperature 12.3, but that's Celsius. So I got to add that to, or I got to add 273 to that, right? Convert it to Kelvin. Temperature always has to be in Kelvin, so 285.3 Kelvin. So now we can do the math. So moles times R times that temperature of 285.3. And my math's all over the place. So 285.3 times R times moles. And I get like 0.7398. And then I got to divide by 1.06. And I get my final answer, my final volume as being I hope if I wrote it in the right place, 0.698 liters of CO2. Now again, I know that was a really tough one right there. And again, if we just kind of wanted to walk ourselves through it again, we're doing gas stoichiometry under non-standard conditions. Our given was that 1.396 grams of CO2. Again, be careful. We have a temperature and a pressure, but that doesn't help us with the stoichiometry. So I changed my grams of CO2 to moles with the molar mass. Then I used my mole ratio to get moles of CO2. And then I thought to myself, oh, I can't use 22.4 liters because we're not at STP. So I stopped my stoichiometry at that point because I have to use the ideal gas law. I have to use PV and RT at that point to change from moles of CO2 to liters. And so I could plug my moles of CO2 into Pivnert, solve for volume, and then we have our final answer. I know, it's a lot. Let me do another one for you all though here. Let me do number 6. So number 6, if 14.4 liters of ethane is combusted at 102.7 degrees Celsius and 744.8 millimeters of mercury, how many grams of water will be produced? So again, recognize it as being stoichiometry. We have the balanced equation, and I'm being asked to convert from liters of ethane to grams of water. So, okay, I think to myself, my given is 14.4 liters. And I know my first step in stoichiometry is to go from liters to moles. And it's gas. I think I should be able to use 22.4 liters like we did up here in number 3. But what's the catch? That's right, we're not at STP. We have a different temperature and a different pressure. So how do we convert between liters and moles if we're not at STP? So again, if we're not at STP, we have to use Pivnert. So I need to start plugging things in. I start with my pressure. Because again, first thing I need to do in this problem is get liters of ethane to moles of ethane. But I can't use 22.4, but because I have volume, I have a temperature, I have a pressure, the ideal gas law has all of those, I can plug everything in and I can solve for moles. So I look at my pressure. It's millimeters of mercury. That doesn't work though. Guess what we have to do? We got to change it to atmospheres. Guess what? 760 millimeters of mercury is equivalent to 1 atm. So 744.8 divided by 760. And my pressure is 0.98 atmospheres. Maybe I should go 0.8900 atmospheres. The volume, I have 14.4 liters. That's the correct unit for volume. I'm solving for moles. R I know is 0.08206. And temperature, should I plug in 102.7 degrees Celsius? Nope. I need to convert. I need to add 273. And that final answer would be 375.7 Kelvin. So 0.98 times 14.4 and then divided by 0.08206, and then divided by 375.7, and I get for my moles, I think we should be good, 3 sig figs here, 0.458 moles of ethane, C2H6. Wow, okay, so I have moles of ethane, and I think I'm done, right? No, that's just the first part. That's kind of why doing gas stoichiometry under non-STP conditions is kind of annoying, because we did the ideal gas law, we did all of that work, but we're not done. Because Pivnert is just letting us convert between liters and moles. So now that I know how many moles of ethane we have, now we can do the stoichiometry setup. And now that I have moles of my given, I can go to my mole ratio. I'm going to leave moles out just to save some space here. And I want grams of water, so that's 6 moles of H2O on top. And then I know to go from moles to grams, I can use my mole ratio, not mole ratio, molar mass of water. So 0.458 times 6 times 18.02 divided by 2. And again, I think 3 sig figs here. My final answer would be 24.8 grams of H2O. So again, 5 and 6, not at STP, tricky, because we have to use PV equals nRT as our way to change between liters and moles of our gas. Good luck with the rest of the page. Just the answers should be posted. You can always reach out and email your teacher to get extra help. I probably will actually maybe post a video doing a couple more in the coming days as well.